Good morning and welcome to our second part of integration. So we are dealing with these problems. We dealt with numbers 1 to 3, which were basic integration problems. Now, let's continue with examples which are a bit tricky, that need simplification first. Right, like this one. So how are we going to integrate something like this? Okay. So this is definitely not in standard form. So what is the standard form? In standard form, you need to separate terms. Right? You need terms basically you need term by term. So what do I mean? So you can't have division there. You need everything in the form k x to the power n in this case. So we've got a problem with the numerator. How do we simplify this? How do we simplify this numerator? So what do we notice about the numerator? We have a power 3 there. Can you see that? So there's a negative sign here. So probably this can be factorized. And probably the denominator is one of the factors. Right, so you won't get a question that cannot be simplified in N4, only in N5. In N5, then we use long division to work out something like this. Right, so now, let's take, this is the sum of, the sum and difference. Okay, so this is the sum and difference of two cubes. So you might encounter something like this here. The formula is not given to you on the formula sheets, right, for the difference of two cubes. So in this case, we've got the minus. If it's a minus, it's a difference of two cubes. If it's a plus, then it will be the sum. So let me give you the formula. So we've got a to the power 3 minus b to the power 3. That is the difference of two cubes. So in order to factorize this, if it's a minus sign here, then it will be just a minus b, your first factor. Then what you will have here is a squared, and the last term will be b squared. So the first and last is always positive. But the middle term here, if this originally is a negative, then the middle term, you change the sign, that will become plus a b. There is no 2 here. Okay, there's no 2. For those of you who are thinking about the 2, that means you are thinking about this formula here, a minus b all squared. Do not confuse that with this one here. So a minus b all squared can be written as a squared minus 2ab plus b squared. But this is a cubed minus b cubed. Right. Now, what happens if it was a plus sign? Let's write it down. If it was a plus sign, then this can be written as a plus b, and then it's going to be square the first, take a squared, take your last term, squared. But now, remember what I said with the difference and sum of two cubes. So if this is a plus, this will change to a negative. You can test it out. How do you test it out? Remove the brackets. Multiply this whole thing out, you'll get back to a cubed plus b cubed. If you remove the brackets here, you'll get back to a cubed minus b cubed. Right, so we have to remember our stuff from N3 here. So let's take this example, 27x to the power 3 minus 1. So 27, first of all, find the cube root of, you take your calculator, if you're under pressure in the exam, just go cube root of 27. And what will you get? You should get 3. Right, so therefore, this 27 is the same as 3 cubed. So that becomes 3x all cubed. And it becomes 3x all cubed because 3 to the power 3 gives you the 27. Then I've got minus, this has to be a cube. Since it's 1, we can write down any power we like, and we decide to choose the power 3 because 1 to the power 3 is still 1. So what's happening here? So I've got my a, which is 3x, I've got my b, which is 1, and I will factorize this here. So it's going to be a minus b. All you're doing is substituting for a, substituting for b there. So it's going to be 3x minus 1. Okay. Then here it's going to be a squared minus ab plus b squared there. What is a? What is b? Let's write that down. A is 3x, so that's a squared minus a, which is 3x, b, which is 1, and then your b here is just 1. Right, so we've got that sorted. Now, let's transfer it to our integration problem. Alright, so remember I told you the clue is always here in the question. So that's going to be my 3x minus 1 as my denominator. And let me transfer this here and show. You need to show how it cancels it. Alright, so now that's going to be 3x minus 1 and then this whole part here. So 3x all squared, 3 squared will give me. So that's 9x squared minus 3x, and then I've got 1 squared there, which is 1 dx. So as you can see, 3x minus 1 and 3x minus 1 cancel. So let's write down what remains here, which is 9x squared minus 3x plus 1. Right, so the crucial step was the factorization. Now, the integration here in N4 is straightforward. Okay, you're not doing any integration by parts and integration of trig functions, powers of sine and cos. That's all coming next semester in N5. For now, you integrate only term by term. So what's going to be happening here is we've got the integral of k x to the power n dx. Right. So every single term here satisfies this condition here. Okay, what is this condition here? Where you have a power of x, and this will work out to kx to the power n plus 1 all over, n plus 1 plus c only. So there's a condition only if n is not negative 1. Okay, there's a condition to everything here. So this works for everything except the power negative 1. We're going to deal with that power negative 1. So we've got term 1, kx to the power n. Term 2, kx to the power n. Even term 3, you can even write it down as kx to the power n. Right, but let's integrate this here. So I want to integrate 9x squared. Now, when you are integrating, be careful. This is the question at the moment. This is the question, this is still the question, and this is still also the question. It's just a simplified version of the original question. So it must have the integration sign and the dx if you are integrating with respect to the variable x. So even here too, I've got my integration sign, I've got dx. Only now when I apply the integration formula, then I automatically leave out the integration sign and the dx. So now, from here it's a simple thing to do. That's going to be 9x, it's going to be 2 plus 1, which is 3 all over 3 there. And I've got minus 3x, and I've got 1 here, 1 plus 1, which will be 2 over 2. Be careful, do not write down 0 here. Right, a common mistake is students go and confuse differentiation with integration. Remember, this is an answer to a differentiation problem. Every single term here is an answer to a differentiation problem. Right, so that means 1 is an answer to what? Something has been differentiated. What did we differentiate to get 1? We've got x, so let's be more accurate. Basically it was 1x. If it was a 3, it will be 3x. You're clear with that? And then I've got, let's write this down properly, so that's plus 1x, and then I've got plus c. Is there anything more to simplify here? Oh, I can go 9 divided by 3, which is 3 x cubed. There's nothing more to do. I'm just going to copy it down as it is. So that was the first example. Make sure you're clear with that, and let's get ready for the next one. Alright, so before I deal with the next example, correction pointed out by my students. I made a mistake here when I, instead of the positive, I put the negative here. So let me just correct that. So there's a formula here that is a cubed minus b cubed. It has a positive, so I'm just changing. That was the error there. That's a positive, 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 positive. That was the mistake. Alright. Now, moving on to the next example. Again, this is not in standard form. Okay, so what is the standard form? You need to know your identities here. Alright, so the identities are not given to you on the N4 formula sheets. What do I mean? Something like this here, 1 over cos. You need to know what is 1 over cos, 1 over sine. So in this case, 1 over cos is equal to sec, but be careful, you have a fraction here. This is 1 over 2. So the 2 is not attached to cos. Alright, so 2 is part of the denominator, so that becomes, it's just 1 over 2. Okay, I explained to you all when we are dealing with a fraction times a fraction. So 1 over cos becomes sec. Alright, so we've got that sorted. Here, I've got plus 4, 1 over sine. You have to remember all these reciprocal identities. 1 over sine will equal to cosec of 1 over 3x. Okay, minus 5. Now here, this is dealing with exponent laws. So I have e here, which is the base. The exponent is 4x. So this is not in standard form. I need to take this whole thing to the top. And when I take it to the top, the sign of the exponent will change. Remember to copy down your dx, because this is still the question. It's not the solution. It's just rearranging. We are just simplifying. Now, do we need to simplify any more? No. Okay, so now you go to your N4 formula sheets, the one that I gave you, and you see what's given to you, what's not given to you. Okay, so let's take sec. If I'm not mistaken, sec is given to you. But this is the way that you should learn it. Let me write it down here. So that's going to be k sec of, let me write it as bx. Right. So when you integrate sec, the answer is going, well, k is just a number in front. That's going to be ln absolute value of sec bx plus tan bx, all divided by b. Take note that the exam formula sheet is not a formula sheet. It just shows you examples of the formula. So in the exam, this is what you are shown. You are shown just sec of x. Okay, this is the exam formula sheet. Alright, so the exam formula sheet shows you sec of x, and then you integrate sec, you've just given ln of sec plus tan plus c. Okay, so what do I mean an example? It means that b in the formula sheet is always just 1, even with your derivatives. Alright, you would have noticed that you use the formula sheets. So the way I am writing it down is in general. Now what happens to the b here? We're going to end up dividing by the b and n4. So the problem is a student who is unfamiliar with this will not get full marks because we'll miss this part out. What do I mean? Let's take term 1. Oh, sorry, before I get to that, let's deal with the formula for cosec. Is the formula for cosec given to you on the formula sheets? That is the question. Check it out. Is it there? It's given under integration. So the formula for integrating cosec is ln. Okay, well, k is just a constant in front. It's going to be ln absolute value of cosec dx minus cot dx, all divided by b plus c. So that's a formula for sec, that's a formula for cosec, and this one, the exponential. Okay, let me write that down. So what is the formula to integrate there? That's going to be k e to the power bx. So that's what we are integrating now. So when you integrate k e to the power bx, this has to be a number. So that's k e to the power bx all over b plus c. Right, so this is what we need to know in order to complete this solution here. You see that? Let me just put it here. So now let's take term by term. Right, so this is the information required. Let's take term 1. So I want to integrate half sec of 3x. That means my k is half. The b here is 3. You've got this in your head, you do it one time. Okay, so that's going to be k, which is 1 over 3. And I've got ln absolute value here of sec bx plus tan bx. So that's going to be sec 3x plus tan 3x, all divided by whatever this number is here, which is 3. Right, so that as it is, you can see that all divided by the coefficient. Sorry, that's a 2. That's one number 2. All divided by 3. You're clear with that? Right, so that is term 1. Now let's deal with term 2. Term 2, we're integrating cosec. Okay, so I've got the 4 there. Integrating cosec, that's going to be ln absolute value here of cosec. There's a here, cosec. You just copy it down. Cosec minus cot. So that's going to be cosec of 1 over 3x minus cot of 1 over 3x, all divided by the coefficient of that original function there, which is 1 over 3. And let's deal with the last term. The last term is your exponential. So your k is a number there. Okay, in N4, you will never get an example where k is now changed to a variable. That is integration by parts. That will be in N5. Right, so remember, this has to be a number. Right, so now, integrating k e to the power bx, there's the answer right here. So it's going to be minus 5 e to the power minus 4x, all divided by the minus 4. You're clear with that? As it is, just need to check what's your k, what's your b. And then we put down plus c. Let's see, what do I need to simplify? This part here, 1 over 2 divided by 3. You can use your calculator. This is a fraction divided by a fraction. This becomes 1 over 6. Alright. That's going to be ln absolute value of sec 3x plus tan 3x. 4 divided by 1 over 3 becomes 4 times 3 over 1. Remember your bottom fraction, invert and multiply. But you make sure, you use your calculator, you make sure in the exam it's 100%. So 4 times 3 will be 12. That's going to be ln cosec 1 over 3x minus cot 1 over 3x. And here we have a negative divided by a negative there, which is positive 5 over 4 e to the power minus 4x plus c. The last part is, the integration part is, you have to know the formula. Okay, the problem is the trigonometry. If you forgot all the n3 trigonometry, it will catch up with you here. Alright, so have a look at this. Then I'm going to be erasing the board now in order for me to deal with the next example. Okay, so before I start with the next example, a question from one of my sharp students. Right, so the question was, here you only divide by 3 one time. Why don't you divide by 3 by sec? Why don't you divide by 3 here by tan? So that was the question. Okay, so it will also apply to this here. I've only got divide by 1 over 3 one time. I don't have this divided by 1 over 3, that divided by 1 over 3. Right, so it's whatever you asked here will be the same question here. So now, how do we check now? Why is there only the 1 over 3 there in the bottom? So, as I explained to you now, every single example can be checked in the exam. Before you leave the exam venue, what do? You do differentiation. You differentiate your answer, you get back to the question. That's what it is. So, in order to understand what happened here now, let's go back to the formula ln, because this is ln. Can you see that? Right, so this is ln. So now, we're going back to our table of derivatives. Right, so remember, you need to go back to my video on the table of derivatives. It's not given to you like this in the exam. Right, so watch how this is done now. So if I'm given y is equal to k, again k being a number, not x there. Alright, so a number. So if I go y prime, that means the first derivative. Okay, so this is going to be k. You just copy down the k there. So what's going on here now? How do you work this out? You take f of x, you copy it in the denominator. Alright, and then you differentiate this and you write down the answer on the top, which is going to be f prime x. Alright, so now, if we differentiate, we should have an idea of what is going on here with this integration. Alright, so let's take the answer. There's the answer here. So y is equal to 1 over 6 ln absolute value here of sec 3x plus tan 3x, and obviously it will apply for the next one. Right, so now, in a case like this, when you are reading the question now, after the letter n, after the letter n is f of x, that means after the letter n, everything inside this bracket, you can call it a bracket, but it's absolute value there. Anything inside here is f of x now. Can you see that? So, how do we apply this formula? So, I'm going to go dy over dx. So, k, I just copy it down as it is. There's my 1 over 6. It's just a number in front, a constant. So, now, how does this formula work? You take f of x, you copy it in the denominator. Take f of x, copy it in the denominator, which is sec 3x plus tan 3x. You're clear with that? Now, f prime x means differentiate whatever you have here. Write down your answer on the top. So now you have to go back to your table of derivatives again, because now we are differentiating sec. Alright, did I write down the formula for sec here? Right, now this is integration. Now we are differentiating now. So when you differentiate sec, it's going to be sec 3x times tan 3x times the derivative of your 3x, which is 3. Don't forget that. Exam formula sheet does not show you this here. Okay, now differentiate tan. What is the derivative of tan? Sec squared of 3x times 3. You're clear with that? The derivative of tan of 3x is going to be sec squared of 3x times the derivative of 3x, which is just 3. Now, where was the question? The question was sec. This is it. But when you differentiate it, it doesn't look like this here. Am I right? Remember, in order to check your answer, you differentiate, and you must get back to the question. So it doesn't look like the question now. Let's see what we can do here. Alright. Let's see what we can do, because it looks like this needs simplification. So I've got my 1 over 6 there. Then I've got my sec 3x plus tan 3x here. And the numerator has common factors there. Can you see the common factors on the top? What's common here? Not only sec, also the number 3. The number 3 and sec is common. So therefore, I will take out 3 sec 3x as a common factor on the top. And I'm sure in your mind now you're already working out what's going to happen here. So if I took this out, what am I left with now? Tan 3x plus what? Plus sec 3x, close my bracket there. Now you can see the magic happening. Because sec plus tan and sec plus tan, if I just put a bracket there, will cancel. Can you see that? So that and that cancel. So what remains is 3 sec 3x on the top and 6 in the bottom. So therefore, what is 3 over 6? 1 over 2 sec 3x. And this proves now that we get back, if you differentiate every single final answer, you will get back to the original question. So you know you got 100% in the exam. You don't need any teacher to come and check your solution now. You know what I mean? So there's it. Was it half? There's it here. We got back to this. Can you see that? Alright, so we're ready for the next one. Right, moving on to the next example. Getting a bit more tricky here. Okay, so yeah, we know how to integrate e. The problem is e is within brackets. There's an exponent there. There's division there. So in N4 level, you do not know how to deal with division and with powers. That you will learn in N5. In N4, you will simplify every single example for integration. Whatever you're given, if it doesn't look like the formula for anything from the table of integrals, you know that you need to simplify it, right? So when we're dealing with a question like this, so there's a square there. So basically I have a plus b all squared. That's what I have on the top. Let me just call the bottom c. I'm just recreating let's say a similar scenario here. Okay, so we have to go back and know all our n3 squaring a binomial. That's what we are doing. A plus b all squared. You should be able to do this in one step. That's going to be a squared plus 2ab plus b squared. So that's exactly what we need to do here. And this whole thing is divided by c. Now, let's do it. So if I want to apply the formula as is now, without any mistakes here, identify what's your A, identify what's your B. And just substitute it, but be careful. This part here must be in brackets. In brackets here. Otherwise it will be wrong. Be careful. Alright. So A squared. So that's going to be that will be e to the power minus x all squared. Term 1 squared. That's going to be plus 2 times term 1 times. So that's 2 times a times b. So 2 times term 1 times term 2, which is 2 there. You can see that. And then I've got plus b squared. Always a plus here. Alright. Term 1 and the last term is always a plus. And then the last term squared. All divided by e to the power 2x. Right, so we did that, but that does not solve our problem. The problem is that we still have the division here. Can you see that? It's still not in standard form. So what to do? Go one step further, separate it into fractions. Count how many terms do you have in the numerator. There's term 1 separated by plus sign. There's term 2 separated by plus sign again. Term 3, so therefore I must have 3 fractions. You count how many terms in the numerator. So what do I mean? Like 1, 2, 3. So you're going to go simplify a squared over c plus 2ab over c plus b squared over c. So that's exactly what I need to do here. So I'm going to take each term and I'm going to divide it by e to the power 2x. I'm going to divide by e to the power 2x. I'm going to divide here by e to the power 2x. Okay, now be careful. You might know your integration, but you make one mistake here, everything goes wrong. Be careful. This is now exponent law. You have a power raised to a higher power. So, if I have something like x to the power 2, all raised to the power 3, it's the same scenario we have here. You can see that. When you have a power raised to a higher power, you write down the base. What do you do to these powers here? You multiply, so it's going to be 2 times 3, so that's going to be x to the power 6. So, be careful. This does not become x squared. This is your power here, and that's the higher power. So what you're actually doing is, you are taking minus x and you're multiplying it by 2. That's multiplying the powers. Can you see that? So that's going to be e to the power minus 2x. Here, let's see what's going on here. 2 times 2 is just 4. E to the power minus x. Here, 2 squared is 4. What to do from here? Why did we separate it into fractions? Because we can simplify even further. Okay, we can simplify further. What do I mean? If I have x to the power 10 divided by x to the power 3, it's a similar scenario where the bases are the same. Can you see that? When the bases are the same, you write down the base one time, and then you go top power minus bottom power. Right, so that is going to equal to x to the power 7. So that's exactly what we need to do here. So that's going to be the integral there. Let me just write down the base there, which is e. So I'm going top minus bottom. Be careful. The top is minus 2x. Minus 2x. So minus 2x, minus 2x. What does it give you? Minus 2x, minus 2x will give you minus 4x. You're clear with that? Top minus bottom. Right, so now, here, coefficients divide by coefficients. Be careful here. 4 divided by 1, that will give me 4. Write down the base. The equal base there is e. And now, exponent law. Top minus bottom. So minus x minus 2x, which will give me minus 3x. Alright, here I've got my plus 4 there times e. Now, okay, I'm writing down e there. What I've actually done is I'm taking the base from the bottom to the top. When I change position from bottom to top, in other words, from denominator to numerator, then what happens? The sign will change. Originally, it's a plus. It changes to minus. So that's minus 2x. So now, it's just a simple integration problem. Because what are we doing now? All we're doing is we are integrating e to the power bx. And when you integrate e to the power bx, it's going to be e to the power bx all over b plus c. And that is the easy part to do. Now you realize that integration, the formula is easy. The problem is the simplification here. If you get something like this here. Right. So let's go term by term and integrate them. Nothing to explain now. That's going to be e to the power minus 4x all over minus 4. Whatever you have here, don't forget to divide in the bottom there. Can you see that? Then the next one, there is plus 4 e to the power minus 3x all over minus 3. And the last term there is plus 4 e to the power minus 2x all over minus 2. Finally, you write down plus c just one time only. You don't have to write it down 2 times, just one time only. Let's just neaten this up for 100%. Right, so let's write it down properly now. So I've got a positive divided by negative, so that becomes minus 1 over 4 times e to the power negative 4x. You cannot leave it like this, you will not get 100% here. Positive divided by negative is a negative 4 over 3 times e to the power negative 3x. Even here too, this needs to be simplified. Positive divided by negative there, 4 divided by 2, that's going to be minus 2 e to the power minus 2x plus c. So you might have approached the example a bit differently. So this is what you are possibly thinking. That why you could have taken e to the power 2x to the top, and it becomes e to the power minus 2x, and then you remove the brackets. You're going to come to the same. Okay, I just left it as it is and I separated into fractions. You can try it out, you come to the same thing. Let's get ready for the last few examples here. Alright, so let's deal with the next example, dealing with some trigonometry now. Okay, so here, if you look at the numerator, there's a square. So straight away, you must think square identities. But also what comes into mind is double angles. Because this is a 2 here, so you're thinking now, okay, is this dealing with double angles or not? So let's check. Do we need to apply our double angle formulas? We will only be required to apply the double angle formula is when the angle is different for one of those two. Like let's say this was just P, then we've got a problem. We have to apply the double angle formula. Right. But now the angles are the same, so therefore we can simplify sine of a cos is tan, cos of a sine is cot, only if the angles are the same. So before we come to that part where we're going to simplify that, let's look at the square identity. So I've got 1 minus cos squared. Now, most students forget what is 1 minus cos squared. Okay, so when you look at your formula sheets, you don't see 1 minus cos squared. What do you see then? You see that sine squared plus cos squared is equal to 1. So let's take that information as it is and replace the number 1, because that is exactly what you see there. Alright, let's see what happens. So you forgot that you can do this one time, so you apply the formula for 1, which is sine squared. In this case, you follow the angle, sine squared 2p plus cos squared 2p. So I have replaced the number 1, but don't forget there's also minus cos squared 2p. So whichever way you do it, you're going to come to the same thing. So what happens now in the numerator? What do you notice happens in the numerator? Cos squared 2p and minus cos squared 2p is just 0. So what remains is sine squared 2p. Again, if you knew this off by heart, you just write it down one time. You can go straight. 1 minus cos squared is sine squared. That is acceptable. Right. Now, you notice that the angles are the same. Okay, the angles are the same, so therefore I can simplify sine of a cos. Now, here you might think, now I've never seen the identity for sine squared of a cos squared, or sine to the power 10 of a cos to the power 10. So how does it work? It's actually sine 2p all over cos 2p all squared. I'm just going into more detail of the exponent here. Right, for those of you who most people will not realize that this is just an exponent law. Look at the common power. Can you see the common power? I wrote it down once. Okay. So now I can simplify sine of a cos, which is 10. So that's going to be 10 of 2p. And let me just put the power back where it was. Right, in this position. 10 squared, 2p. dp, don't go and write down dx, follow the variable given to you in the exam. Okay, now you need to think now. Do you have a formula for tan squared? You go into your formula sheet now. You're looking under integration. You're looking for tan squared. There's no formula. There is no formula for tan squared. Because there's nothing that you can differentiate that gives you tan squared. Okay, that's why. So, what to do? What to do? Okay, so how can you relate tan? Do you know about anything about tan and the derivatives of tan from your table of derivative? What do we know? We know that if y is equal to tan of x dy over dx, you have to think differentiation, even though you're doing integration here. Everything is linked here. So if I differentiate tan x, what do I get? Sec squared of x. So what does that mean? It means if I integrate sec squared of x, I must get back to tan x. So, you know that, but we still got a problem here. We do not have sec squared, but if you look properly at your formula, square identities, there is an identity here for tan squared. What is the identity for tan squared? The identity is 1 plus tan squared. In this case, 2p is equal to sec squared 2p. That's a square identity. Now, if I make tan squared the subject of the formula, so I'm going to go, therefore, tan squared 2p is equal to sec squared 2p minus 1. So we use the square identity, we manipulate the formula, and we rewrite tan squared as sec squared 2p minus 1. In brackets, don't forget your GP there. So now, why did we do this? Because we know if we differentiate tan, you get sec squared. You integrate sec squared, you get back to tan. Right, so integrating sec squared, there's it there, that will be tan 2p. Don't forget there's a 2, so it will be divided by 2. The formula sheet does not show you all this here. Careful. Alright, so minus, don't make a mistake now and write down x here. This is p, so you will write down p. Everything is with respect to the variable p, right? Plus c. Now, why do I have number 7 written down twice? Because what happens if you chose a different path to do this, a different way? Okay. So, let me just do it here now. Okay. What happens if you decided to separate into fractions like what I've done here? Why not try it out there? Let's see what happens. Alright. So, how many terms in the numerator? 2 terms. So therefore, 2 fractions. Clear with that? Common denominator here is cos squared 2p. Then I've got my cos squared 2p there. That's my line there, and there's my GP. So what I want to do now is separate them into 2 fractions. So it will be term 1 over the LCD minus term 2 all over the LCD. Just like what I've done here, you can see that. Okay, now simplifying. Okay, what is 1 over cos? Now this is not given to you again. If you want to get 100% here in N4, you make sure you know your trigonometry properly. Alright, so 1 over cos squared is sec squared. Obviously, cos squared divided by cos squared will give me 1. So what happens here? We get to this part faster now using this technique here. Can you see that? We get to the same part, sec squared minus 1, faster by separating into fractions. And now integrate sec squared, you get tan 2p all over 2. Integrate 1 with respect to p is just p. Are you clear with that? Plus c. Right, let's get ready for the next 2. We'll do that fast because now you know what to do. Right, so let's deal with these ones a little bit more simpler. Let's finish up these 2 examples here. So, This should not be a problem on how to approach because you've just done number 6. All I've done was change it to Q. I just put Q. But the style of the question is the same. Okay. The fact is, this is not in standard form. We have to simplify. That's basically this. It is not in standard form. There's a square there. We'll have to square it. So now, we're going to square this in one step. So this is equal to, if I square this, this is going to be Q squared, term 1 squared. Term 2, with the middle term will be 2 times term 1 times term 2, which will be 2Q. The last term will be 1 squared, which is 1. Now, I'm going to simplify, do it one time. Remember that you know that the next thing is to separate each one into fractions. So that means I'm going to go term 1 all over Q to the power half, term 2 all over Q to the power half, term 3 all over Q to the power half, dQ. We're separating into fractions because we need it term by term here in integration. So we have this situation here, exponents. There's a lot of exponents here involved in integration, you can see that. So, but not the difficult exponent problem. It's just a simple step. Remember, when you are dividing and the bases are the same, what do? You write down the base once and then you go top power minus the bottom, or top exponents minus the bottom exponents. So 2 minus half is 1.5, which is 3 over 2. Right. 2 divided by 1 here is 2. 1 on the top, you know, if you don't see a number, it's positive 1. 1 minus half is just half. This, take it to the top, sign of the exponent changes. Now that you've gone through all this process, you find this one a little bit easier to do. Okay. So now, integrate. So you're integrating. Now, remember, do not copy down the integration sign of the dq. So now when you integrate, you know you're going to go plus 1, copy down the same in the denominator. So 3 over 2 plus 1, that's going to give me 5 over 2, all divided by 5 over 2. Then we've got a half plus 1, that's going to give me 3 over 2, all divided by 3 over 2. And the last one there is minus half plus 1, that's going to be 1 over 2, all divided by 1 over 2. Don't forget to put down plus c. Now the simplification part for 100%. So let's simplify this here. 1, obviously, if there's no number, it's a 1. So it's 1 divided by 5 over 2 becomes 2 over 5. Okay. Now this part here, I'm going to rewrite it back in third form. So how do you remember how to rewrite it back as a root? Okay. You've got the numerator, denominator. Remember, the denominator is the number, the root. Okay, so it's if it's a 2, it becomes square root there. Can you see that? And then the 5 becomes the exponent. So that's q to the power 5. Let's deal with the second term. 2 times 2 will be 4 over 3. It's a 2 there, so it becomes square root of q to the power 3 there. And then the last term, 1 divided by half becomes 1 times 2, which will be 2. And that's a square root of q plus c. So it is acceptable to leave this blank because a blank space means the 2. That's how it is by default. Right. If you write down the 2, it's still correct. You don't have to. It's like writing down the power 1 and leaving it out. Okay, it's understood that it's acceptable. Alright, let me finish the last one here quickly. Let me finish this one. This one will be quick. Alright, so now what situation do we have here? Okay, so let's go back to, remember this, when you have k x to the power n, your n must not equal to -1. N must not equal to -1 when you apply the formula. So basically you cannot apply the formula if your n is -1. That's basically what I mean. So if you have something like x to the power -1, okay, what happens when you apply the formula? So remember, what you must do is, if they tell you don't do it, you must actually do it and see why it is wrong. So let's do it. Let's see why this is wrong. So there is going to be x, and then you're going to go -1 plus 1 minus 1 plus 1, which becomes -1 plus 1 is 0, -1 plus 1 0. X to the power 0 is 1, but the problem is that 0 in the denominator. That's undefined. You can't divide by 0. Only you can approach 0, that's limits, but you cannot actually divide by 0. So what to do in a situation like this? In a situation like this, you are going to take the x to the power -1 and make your power positive. Write it as 1 over x. Write it as 1 over x. So when you are writing it as 1 over x, now it means that we are dealing with the situation f prime x all divided by f of x. Okay, this is the proper formula. Not this one here which you see on your formula sheet. It is just an example. Okay, this is the proper formula to learn. So f prime x on the top, f of x in the bottom. What does it mean? It means you have a function of x. If the denominator is what? X. And the numerator is an exact derivative of the denominator. That means if I differentiate x, I get 1. The condition is satisfied, so therefore the answer will always be ln absolute value of the denominator plus c. So in a case like this, 1 over x, it's going to be ln absolute value of x plus c. That's all. So now you know what happens when it's a -1. Right. So now let's do this. This one will only take 2 steps. So let's check term 1. Term 1 has a power 1. If I take it to the top, what will happen there? Like term 2, I can do this with term 2. It's going to be 5k to the power -2. If I take term 1 to the top, it's going to have an exponent of -1. You're clear with that? So you do not want an exponent of -1. So you write it as -2 multiplied by 1 over k. That's how you set up your problem in N4. Right, you write it as your constant times 1 over x. Or in this case, it's 1 over k. So now we can integrate. It's satisfying this condition here. Term 1 I'm talking about. Term 1 satisfies this condition. So that's going to be -2 integrate 1 over k. That's going to be ln absolute value of k. If it was x, it will be ln x. Okay. This satisfies these conditions here when it's not a -1. So we can go and add. That's going to be plus 5k. And then -2 plus 1 will give me -1 over -1 plus c. Problem solved. I think we are ready to deal with any tricky examples now. So that's going to be -2 ln k. Positive divided by negative is a -5. I want to simplify this for 100%. So that's going to be k to the power -1. Take it to the bottom. It's back to k to the power +1. You can see that. Plus c. So some nice examples, tricky examples involving trigonometry. Basically, if you want 100% in N4, make sure you know your trigonometry properly. Make sure you know your exponent laws properly. See? Your double angles. Double angles are not given to you. But I don't have a double angle here, but you can check it in my other videos. So make sure you know that. So we continue next time.